Shri Gurubhyo Namaha children. Welcome to our online teaching academy Ekalaiva. Today I am going to teach exercise 7.3 question number 8. How many words with or without meaning can be formed using all the letters of the word equation, using each letter exactly once? Right? Here how many letters are there? You have to count and see first. 1, 2, 3, 4, 5, 6, 7, 8. So, solution. There are 8 different letters. There are 8 different letters in the word equation. Here what they said, you see, with or without meaning, using all the letters of the word. That means 8 letters taken 8 at a time, right? 8 letters taken 8 at a time. That is the meaning. So the number of permutation number of permutations of 8 different objects, that is 8 different letters taken 8 at a time, because they said all at a time. Taken 8 at a time is 8p8. You have to recall the general formula. N equal to n factorial. So 8p8 equal to what? 8 factorial. Therefore, the required number of words, that can be formed equal to 8 factorial. You know how to write the factorial, right? N factorial means n into n minus 1 into n minus 2 etc. up to 1. So you have to write it in the reverse order. That's it. 8 into 7, 6, 5, 4, 3, 2, 1. The same way you people learned in the PT while during the games, right? Exercise. Now you see 8 sevens are 56, 6 fives are 30, 4 threes are 12, 12 into 2, 24. Then 56 into 12 remaining 1, 7, 20. Then 56 into 72 you have to multiply. 12 remaining 1, 42, 43. 10 remaining 1, 35, 36. 2, 3, 0, 4. So your answer is 4, 0, which is equal to 4, 0, 3, 2, 0. Got it, children? Now, next question number 9. The same way. How many words with or without meaning can be made from the letter of the word Monday? Here how many letters are there? 6 letters, 6 different letters. Assuming that no letter is repeated, first condition 4 letters are used. That means 6 different letters are there. You are going to take only 4 letters. Which 4 letters we don't know. At the same time, no repetition, right? Different letters only you want to take from the 6 letters. Now you see solution. There are 6 different letters in the word Monday. First subdivision, they said you have to take 4 at a time. So, the number of permutations of 6 different letters. In general, you can say objects, right? 6 different letters taken 4 at a time. Taken 4 at a time is 6p4. Number of n things taken, sum at a time, that concept, right? Sum at a time means only 4. The previous one, the 8th question, number of n different things taken, n or at a time, right? All the things, all at a time. Now, the required number of words can be formed using 4 letters at a time is equal to 6p4. What is the formula for NPR? You have to recall the formula, right? NPR equal to n factorial divided by n minus r factorial. Here, 6 factorial divided by 6 minus 4 factorial, which is equal to 6 factorial divided by 2 factorial. The numerator only you can expand, right, based on the denominator. Now, which is equal to 6 into 5, 4, 3 into 2 factorial divided by 2 factorial, which is equal to 30 into 12, 360. 360. Now, the second subdivision, they said all letters are used at a time. Second subdivision, the number of permutations 6 different letters, 6 different letters taken 6 at a time. Time is 6p6 ways, right? Taken because they said all letters are used at a time. So 6p6, which is equal to, that is the required, which is equal to what? 6 factorial. The required number of words can be formed when all letters, what it is given, that you have to write it again. When all letters are used at a time or used at a time equal to 6 factorial. We are going to write it in a reverse order, which is equal to 6, 5, 4, 3, 2, 1. 720. 720. Now I am going to move to the third subdivision. What is the third subdivision? You have to read. The third subdivision is all letters are used, but first letter is a vowel. First letter is a vowel. In the given word, how many vowels are there? In the given word, O and A, only two letters are the vowels, right? In the given word, there are two different vowels. Two different vowels. Which have to occupy the rightmost place of the word, the rightmost place of the words formed. Rightmost place of the words formed. This can be done in two ways, because two vowels are there, so two ways. The remaining 5 places. For example, O is occupied in the first place, means the remaining 5 places, can be filled by the remaining 5 letters, It can be done in 5 factorial ways. That is 5p5, that can be written as 5 factorial. Therefore, the required number of words that can be formed equal to vowels. So that should be 2 ways into 5 factorial. So 2 into 5, 4, 3, 2, 1, which is equal to 2 into 20 into 6, 120, which is equal to 240. Got it, children? Now I am going to move to question number 10. What it is given, you see, in how many ways, in how many of the distinct permutation distinct permutation of the letters in Mississippi, letters in Mississippi, 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 do the four, do the four eyes, not come together, not come together. Not come together. If the letters are same, the formula is n factorial divided by p factorial into q factorial into r factorial, etc. Right? Or in other words, the objects, see, the number of permutation of n objects where pi objects are of same kind, p2 are of second kind, p1 objects are of one kind, p2 are of second kind, etc. pk are of kth kind, then it can be written as n factorial divided by p1 factorial, p2 factorial, p3 factorial, etc. Right? If the letters are same, if the letters are repeated twice, thrice, means the formula is n factorial divided by p1 factorial, p2 factorial, p3 factorial, etc. up to pk factorial. Permutation when all the objects are not distinct, right? Permutation when all the objects are not distinct. Means this is the formula. N factorial divided by P1 factorial, P2 factorial, etc. Pk factorial. Got it? Why we are applying this? Here S, I and all repeated 2 to 4 times, right? That's why all the objects are not distinct category. Now, the number of in the given word Mississippi, I appears 4 times, S appears 4 times, P appears 2 times, P appears 2 times, and M appears just once. Just once. Now, number of permutation, distinct permutation, number of distinct permutation of the letters in the given word equal to Mississippi. When you count, you will get it as 11. So n can be replaced by 11 factorial. P1 can be replaced by 4 factorial. P2 4 factorial. P3 2 factorial and pk, that is the last term, 1 factorial, right? Now, which is equal to 11 into 10, 9, 8, 7, 6, 5, 4 factorial divided by 4 factorial. Then 4 factorial, you write it as a reverse, 4 into 3 into 2 into 1 into 2 into 1. See 4 factorial cancel. 4, 3, 2. See 4, 2. Then 8 cancel. 3, 2. 6 cancel. Then what should be the rest? 11 into 10 into 9 into 7 into 5, which is equal to 3, 4, 6, 5, 0. Have to multiply and check. Then the next subdivision, what it is given, you see, the 4 i's are not together, they said. But we are going to find if it is together, how it will act. There are 4 i's in the given word. In the given word, when they occur together, they are treated as a single unit. They are treated as a single object or single unit. Single unit in the sense like this, I. The single object together, with the remaining out of 11, 4 as a single unit. So how many remaining letters are there? With the remaining 7 objects, will account for 8 objects. 8 objects. Now, 8 objects in which there are 4 S's and 2 P's. P, right? Twice time the P's exist. 2 P's can be arranged in 8 factorial divided by 4 factorial into 2 factorial, which is equal to 8 into 6, sorry, 8 into 7, 8 into 7 into 6 into 5, 4 factorial, divided by 4 factorial into 2 into 1. Cancel, then 4. 20 into 42, which is equal to 20 into 42, 840. But we need what? Number of distinct permutation. Number of distinct permutation. Number of distinct permutations of the letters in Mississippi. Letters in Mississippi in which 4 eyes do not come together. Do not come together. We had a total. From that you have to subtract 840. You will get the result what they are expecting. Right? 34650 minus 840 equal to 33810. 840 when 4 eyes are together means the number of permutation is 840. But we need 4 eyes do not together. That 840 you have to subtract from the total. You arrive the result as 33,810. Thank you, children.